Hey everyone, this is Mrs. Anderson. We're going to talk about radicals today. This is like the third time I've tried to record this video because of a rooster that won't be quiet. So let's hopefully get through this. Alright, so radicals are like square roots. I'm sure you guys know about those. So if we look at this, the number inside is the radicand. And sometimes there's a number out here, that's your index. And radicals are roots. That's why we say square roots. That's a type of radical. And these do look like division symbols, but they are not. Has a little check. This is a cube root because it has a 3. And then anything beyond that would be like 4th root, 5th root, 6th root, and so on. So those are basically what radicals are. We are going to simplify them. Before we start simplifying, I'm going to give you a couple to warm up, some mental math, because I'm pretty sure you guys remember most of these, hopefully. Okay, so square root of 36. 6, because 6 times 6 is 36. Square root of 4, 2, square root of 100, 10, and square root of 1 is 1, because 1 times 1 is 1. So hopefully that brings back some memories. What if our radicals weren't perfect squares like these, meaning it didn't come out to an exact whole number? Well, that's what I'm going to show you how to do. So these are just simplifying radicals. Let's start with something like square root of 63. We are going to use what we call the factor tree. So 63 breaks up into 9 times 7. And we can't break up 7, but we can still break up 9 into smaller numbers. So 9 would be 3 times 3. And now I can't break down anything else. So I'm going to rewrite these prime numbers into my radicals. I have 3 times 3 times 7. Since this is a square root, we know square goes with the exponent 2, right? So we're looking for groups of 2. We're looking for pairs. And 3 times 3 would be a pair of 3s. So that means I'm going to bring out one of those 3s. For every circle you make, only one number comes out. Just like here, we would have 2 times 2 makes 4, but only one of the 2's come out, right? So I'm going to bring out my 3 to the front. What do I have left over? Well, I used up those, so I only have a 7. Okay, so that would be your answer. And you read this as 3 square roots of 7. Okay, let's practice a few more. Well, let me give you one with way more numbers. So let's try square root of 32. Again, start with the factor tree. So 32 is 8 times 4. I can break up 8 into 2 times 4, but I can still break up the 4's to 2 times 2 and 2 times 2. Let's see, have I broken down everything? Yes. I have a lot of 2's here, so 1, 2, 3, 4, 5. 5 2's. So I'm going to rewrite that here. So there's my 5 2's. This is a square root problem, so we're looking for pairs, so groups of 2. there's one group of 2, there's another group. So that means I have one of the 2's coming from this circle, one of the 2's coming from that circle. So there's my 2 for the first one, there's the 2 for the second one, and then we have a 2 left over. So when you look at this, you want to think maybe they're looking for a pair so they could come out of the radical. And that's the whole point, that the numbers want to come out of the radical. And they can't do it by themselves. They need another partner. So multiply the outside. And if you had numbers left over inside, you would multiply the inside. So 2 times 2 would be 4. So this is 4 square roots of 2. Alright, let's try something with some variables. Okay, let's do square root of 80x cubed. Okay, don't let the variable scare you. It's still the same process. Let's start with the 80 and use a factor tree. Okay, so 4 times 20. By the way, you can start your factor trees with any numbers. As long as your multiplication's correct, it will work out. So I can start it with 8 times 10. I can start with 2 times 40. In the end, they'll all come out the same. Okay, I can break down the 4 into 2 times 2. I can break down the 20 into 4 times 5. Okay, so 4 again, and it's 2 times 2. So I have 1, 2, 3, 4 2's and a 5. So let me rewrite this. I'm going to write it over here so I have more room. So it becomes 2 times 2 times 2 times 2 times 5. And I have those 3 x's, the x cubed. So x times x times x. I'm just going to write them out like that. And now I can see all my factors inside. So I can get those pairs. So there's one group of 2. There's one group of 2. The x's, the variables, can have groups of 2. Sometimes you can have different variables. Remember, it has to be the same variables, just like it has to be the same numbers. Alright, so let's see. We have a 2 coming from here, a 2 from that circle, and an x from that circle. What's left over? 5 and an x. Okay, let's simplify. 2 times 2 is 4. X square root of 5x. Let's do one more and then I'll show you how to do cube roots. So number 4. Let's do 5 square root of 8p squared. So for this one we have a number outside, but you're not going to worry about that until we get to this stage. So for now, let's focus on a factor tree for the 8. So 8 is 2 times 4, and 4 is 2 times 2. So I'm going to write over here. I have a 5 outside. I'm not going to worry about it now. I'm just going to leave it there. 2 times 2 times 2. And then I have p squared, so p times p. And we're looking for groups of 2. So I have these 2, and that means they're going to come out. So I have a 5 outside. I'm going to leave that 5 there. I'm bringing a 2 from this circle, and I'm bringing one of the p's from this circle. And what's left over? Just the square root of 2. Alright, let's multiply the outside. We have 5 times 2 is 10. P square roots of 2. Okay, let me show you a cube root. Now the cube root is the exact same way like all of these, except instead of groups of 2 for square root, we're doing groups of 3 because cube is 3. So I'll show you one so you know how to do it. Let's see. Okay, so cube root means there's a little 3 there in your radical. So let's do cube root of 32. I'm just going to show you with a number, but it would be the same if you had a variable. So we did a factor tree on top earlier, and we had 8 times 4, 2 times 2, 4 times 2, and 2 times 2. So there were 5 2's. So I'm going to put 5 2's. I'm sorry. 2's. And I'm looking for a cube root, so groups of 3. So I have one group of 3, and that's it. So that means one of those. Oh, you know what I forgot? This was a cube root, and I have to put that little 3 here. That's important. That's part of the answer. Or else we would think it's a square root. So I'm bringing out the 2. What do I have left over in my cube root? Let's see, I have a 2 times 2. And we're going to multiply that out to simplify. So you read this as 2 cube roots of 4. And that would be your answer.